Hi, everyone. Welcome. Thank you for coming. My name is Vladik Romanovsky. I'm one of the maintainers of the KubeVirt project. And today I would like to share some of the progress that KubeVirt had over the past year, some of the changes in the community that occurred, and the features that we've been working on, and in general, our plans for the future. So for those who are not familiar, KubeVirt is an operator that extends the Kubernetes API server. All right, so sorry about it. For those who are not familiar, KubeVirt is an operator that extends the Kubernetes API server to allow users to run virtual machines alongside pods. And this is all the same. This is all using the same familiar Kubernetes APIs. And we achieve this by running our virtualization stack in a pod. And this pod is unprivileged and untrusted component that all the security policies apply to it as it would to any other default pod in Kubernetes. Recently, we submitted our application for graduation in CNCF. This project started around 2016, and then we joined CNCF in 2019. So it's been a long journey, and for us, this is a huge milestone. And I provided a link here to our application for those who are interested in tracking the progress. As KubeVirt evolved, we adopted some of the concepts from Kubernetes, and the special interest group is one of them. Over the years, we established a number of SIGs for compute and storage and networking and many others. And this year, we realized that there's a need for another one that will be dedicated for taking ownership and maintaining the shared parts of the project, such as controllers and the APIs. And for this, we created the control plane SIG. This year, so KubeVirt already has a number of working groups in place, for example, for code quality and for testing. And this year, we created another one for confidential computing and a special one for the array integration. And you can find all of the meetings and events that are related to the SIGs and working groups on our calendar. You can follow the QR code here. This year, we also had our annual virtual KubeVirt Summit, and there were about 260 attendees, which is a roughly 17% increase from last year. There were 12 sessions from different organizations. And I have a QR code here that links to a YouTube channel where you can find all of these talks. And next year, we are going to have our first in-person summit that will run alongside KubeCon. So as KubeVirt evolved and it's becoming larger and larger, expands to different domains, in order to keep up with the pace and still provide quality releases, we had to change our development cycle a little bit, and we decided to adopt the enhancement proposal process from Kubernetes and kind of adjust it to KubeVirt. And essentially, it means that for new features and major code changes, we now require developers and contributors to submit a design proposal at the beginning of the development cycle. And that means that during the design phase, we're going to review the design proposals, shape them, and then during the development, we are going to focus on reviewing the pull requests that are associated with the approved design proposals, and then help bring these features over the line. And then we'll have some time for stabilization. And this new web process is there really not to increase the bureaucracy, but to kind of concentrate the community efforts on what's matter for the project at every phase. I'm speaking mostly about reviews. And so at the beginning of the development, we have to review the design proposals, then review the PRs that are associated with it, and then focus on the bugs. and then stabilize the release. And that means that no PRs will be merged until the proposals are approved themselves. And with this process, we have a central tracker for every new feature, where you can find all the designs and PRs and the issues and effectively documentation links. But also, we'll see the maturity stage of every feature, whether it's alpha, beta, or is it graduating. And every enhancement will be owned by, and currently is owned by a SIG. And the responsibility of the SIG is to shepherd the proposal and coordinate with other SIGs in terms of API and major code overlaps. Another benefit from this process is that we'll have all the designs in one place, and this allows future developers and not to guess why we took specific design proposals. But the main advantage from my point of view is that we'll now have a clear roadmap that we can transparently share, and I have a link to a tracker of our next release where you can follow all the enhancements listed. During this year, we had 3 different releases, and there were many different features developed, and I won't be able to touch on all of them, but I invite you to follow the QR codes here to get a full understanding of what has been released. The 1.7 release is not done yet. It's still in progress, going to be released in the upcoming days. One of the largest features that was developed this year is the decentralized live migration. And this one builds on a deep re-architecture of our migration controllers. And I have a link to my colleague's presentation about the feature that goes deeper into the dynamics there. What I will say here is that live migration is a central mechanism, KubeVirt. And with this mechanism, we were able, until now, to migrate virtual machines between nodes and migrate persistent volumes of these virtual machines between storage classes, for example, from block device to file system, and the opposite. And the process starts with the administrator or another controller posting the migration object into the cluster, and then it will trigger the migration, but the migration is being tracked effectively on the virtual machine instance object status, and it's similar to the one that I show here on the left. With this process, we would still be able to do that, but now we can migrate virtual machine between namespaces and clusters. And in order to achieve this, we had to adjust our migration object and split the roles of it. So now it can be either source or target, and posting this on a target would create a virtual machine in the receiving mode. And on the source, we'll have to specify how to connect to this target cluster. And then posting this will start the migration process. And then we introduced a new controller that synchronizes the state of the virtual machine instance object between source and the target. And it means that on each of the nodes, the Virt handler, the node component, essentially doesn't feel any change. It still continues to update its own dedicated virtual machine instance object, and it's the responsibility of the synchronizer controller to keep these two in sync. As I mentioned before, this feature builds upon a very deep re-architecture of the controllers, and but besides that, we had to address many of the performance and the stability issues and all kind of corner cases and bugs that we had to bring this feature into completion. We also added a priority queue to our migration controllers. And as I mentioned, the live migration is a central feature in KubeVirt, and we rely on it for performing cluster upgrades, node drains, other critical cluster operations. But also, we are using it for hot plug operations. For example, if anyone wants to add new resources to virtual machine, it would use a live migration process to do this. And in order to distinguish between cluster operations that are more important and user-triggered ones, we had to create a gradation system and put priorities to different operations. And this was mainly needed in order not to starve critical cluster operations with user-triggered ones. And last year, we introduced a live update rollout strategy to update our VM objects. So it means that any change, any declarative change on the VM object would trigger a live update of the virtual machine if it doesn't break the guest ABI. But this also means that, for example, changing CPU and memory would trigger a hot plug operation or hot unplug operation. But not all hot plug operations were using a declarative approach. Some of them, like storage and network, were imperative using sub-resource API. And this year, we streamlined all of these to be declarative on the VM objects. Confidential computing was another hot topic this year. And at the beginning of the year, we added the initial support for IBM Z secure execution, but later we also added the initial support for Intel TDX and the AMD SCV-SMP. And we created a working group for contributors in these domains to be able to collaborate and craft the API that makes sense across all of these technologies, but also to address common issues that they faced. And next, we are going to, in next releases, work on attestation services and try to integrate ARM CCA. And for those who are interested in all of these topics, I invite you to follow the KubeVirt calendar. There are dedicated sessions for all of these work groups. Another hot topic was around DRA, and we created a working group dedicated for DRA. At the beginning of the year, we introduced an initial DRA support. And that unlocked the ability to allocate more complex hardware scenarios. And if you look at the slide, the API that we came up with, it builds on the similar structures, but it's significantly more complex for DRA. And one of the focuses of the new work group would be to look at these APIs, refine them for the benefit of our users. And again, all of these discussions you can join from our community calendar. Some other accomplishments this year, for example, we optimized our IO thread tuning API, and this builds on advances in QEMU. And I have a link to a presentation that goes very deep into how this can be tuned. We also added the support for Passt network binding. Passt is the user space networking that allow us to treat QEMU process that runs in a container as just another user space application that runs in a container without any complex network plumbing that we have to do for other network bindings. And this year we also added the support for seamless TCP migration with Passt. That effectively means that we are copying the state of the socket from source to the target, but it prevents existing clients from disconnecting from the virtual machine during live migration. Another feature that we are adopting from Kubernetes is the image volume, and that allows us to natively mount OCI images as volumes. And we used to have an implementation that is similar to this in KubeVirt. It's called container disk. And this allows us to transition away from container disk that was KubeVirt specific to a native component that now we can take advantage of. And another example of our deep integration with Kubernetes is that now our virtual machines can use a swap space that can be configured on the node. And this prevents accidental OM kills of our virtual machines. And my colleague will have a session about this tomorrow, so I invite you to follow the QR code for the schedule. There's a lot of work that is going on in KubeVirt, and some of the more exciting features that are being developed right now, for example, around multiple hypervisor support and the creation of plugin mechanisms in KubeVirt. So regarding multiple hypervisor support, we're currently building different interfaces across the project. So it will allow us to extend the KubeVirt beyond KVM. And our first target would be to integrate with the Microsoft MSHV. And regarding the plugin mechanism, this is currently in the design. And this draws from the Kubernetes philosophy about extendability and pluggability. Effectively, we want to allow our users to build solutions on top of KubeVirt, extended in a safe way that doesn't break the core and doesn't destabilize the cluster. So this is currently in works. Another important feature is the incremental backup with CBT. This is something that we started last year, and hopefully we're going to accomplish this year. It builds on functionality in libvirt and QEMU. And I have a presentation here of my colleague that describes the feature, but also presents a vision for the future. And effectively, we want to come up with the high-level VM backup CRD that will allow triggering all of these functionalities in an easy way. vGPU live migration really builds on top of vendor driver support. Luckily for us, the NVIDIA already provides supports for this. There's a minor change that KubeVirt needs to do in the live migration process to accommodate vGPU live migration. So that should be achievable in the next release. PCI NUMA topology awareness. This is really important for high-intensity workloads and AI workloads. Those require low latency. This is tricky for KubeVirt because we need to craft PCI controllers, PCI controller hierarchy in libvirt and QEMU, and then match it with the allocated devices, their NUMA affinity, and then match both of them so it will work correctly. So hopefully we will achieve this, at least we'll start this work in the next release. As I mentioned, we are working on better integration with DRA. And this is not just about refining the APIs, but we want to unlock more complex use cases here with targeting specific NUMA nodes, with targeting a complex combination of network devices with GPUs. And in order to do this, we have to integrate with the CPU DRA driver and the network DRA drivers. And this is currently in works. Native support for virtual machine templates. This is really a feature that's inspired by OpenShift templates. And this is a functionality that doesn't exist in Kubernetes. And effectively what we want to achieve is to derive virtual machines from an existing template. And it makes it very easy for backup and restore operations. We want to integrate this so it will be a native component in KubeVirt and without relying on any external operators. So there's a lot of work really going on, and I encourage you to to get involved, we have a Slack channel, and you can find more information about how to get involved on our community page as well. This is all from me. Thank you very much for coming, and I'll be happy to take your questions. Thank you.